Hello, good morning. Okay, thank you. So did you get any chance to prepare these FS commands, Hadoop FS commands? Right? Good. So the storage part of Hadoop is known as HDFS. When it comes to HDFS, what are the two daemons that communicate with each other? Name node and data node. What is the responsibilities of name node? It stores all the metadata, right? So what exactly is metadata? Data about data. Here, data about the cluster, right? Means name node handles all the information of the data nodes, and then all the blocks, files that are present in the data nodes. Now, name node handles this metadata information in two important files. One is FS image file, and then the other one is edits log file. Name node handles metadata information in two important files. One is FS image and edits log files. So what is this FS image has and what is this edits log file has? Whenever you are doing any modifications to the Hadoop cluster, modifications means any activity like Hadoop FS-mkdir, Hadoop FS-put, any modification you do to the Hadoop cluster, that modification will be first logged to edits file. Edits file as a log appended transaction file. Say for example, I have created a directory AVD, right? Now this AVD directory information will be first logged into edits log file with a transaction ID, say for example 1. Next again I have done another directory called AVD2. Likewise, record by record, it will enter into the edits log file. Once this edits log file has been created, the transaction log has been created, its metadata will be created by the name node from the edits log file. For example, this is very important part of understanding name node metadata. So first of all, observe what I am doing, right? Then you can answer, you can shoot your questions. What is the command to start the cluster in 1.x version? Start hyphen all.sh. It will start all the daemons, right? In the Cloudera, there is a Cloudera manager. You cannot start like this, start hyphen all and everything, okay? So this is the best way to learn Hadoop from scratch, right? So JPS. Now, what is the name node web UI port number? 50070. Very good. Wonderful. This gives the name node status, and you can browse the file system. What is this? I told you, right? Safe mode. How many seconds it will wait for safe mode? By default, 30 seconds. Okay. After name node restart, now it is gone. Let me tell you what is safe mode also in this class. Now, what does this says? Name node storage directory. What is this? App Hadoop temp DFS name. What is the type? Image and edits. Means these are the two files in this location where name node stores its metadata information, right? So let's go to this path. If you remember, app Hadoop temp is the temporary directory we have created. Hadoop name node hyphen format has created a new directory called DFS, right? So let's go to this path. CD app Hadoop temp. Under app Hadoop temp, you see DFS, right? Now CD DFS, you see name secondary, name and data. If you see CD name means name node directories, name means name node, data means data node, name secondary means secondary name node. Wonderful. Now you need to go to this path, current folder. What is this? FS image edits. So FS image and edits files are two important files where name node has the complete information of the cluster. Now there is one file called version file. If you see, what does this version file consist of? There is a unique number associated with it. If you see, namespace ID 6875580. This is like a Aadhaar card for this cluster. What is the number name node is having? All the daemons like data node should also have the same number. For example, new window. Go to again the same path, app Hadoop temp DFS. Now earlier I am in the name, right? Now I will go to data. Data means data node folder, where data node stores the data. Data node stores only actual data, means in the form of blocks. Name node doesn't store any data, right? It only stores metadata information. Actual data is stored in the data nodes. Okay. Now there is a current folder here. Every block ID and everything information is stored here. And if you see, there is a version file as well. cat. What's the number? 6875580, which is similar to this number, right? Both the namespace ID should be equal. What is the namespace ID name node is carrying? The same namespace ID data node should have. Now I have observed many of the students while doing JPS, name node is not there. Data node is not coming up. Few people are not configuring mapred-site.xml. So in that case, job tracker and task tracker will not work. So these important configuration files, core-site.xml, where you are giving the name node address, mapped- job tracker address, HDFS, storage information, block size, replication details, and everything you need to give in those files only. Then only the cluster will be recognizing all these parameters, right? If you have any issues while starting the cluster, you need to go to this folder, user, local, Hadoop. There is a logs folder. Now here this information consists of all, if you see, Hadoop HD user secondary name node ubuntu.log. Check the today's date. Suppose if your data node is not working, now go to these logs. Then there is a every file information related to all the daemons. Name node is not running. Go to this path. Why name node is not running? HEAD head or simply tail. What does tail command do? It gives last 500 lines, right? I mean, like whatever number you're giving. I'm just giving 500, copy, paste, enter. Now, if there is no issue, it should show like this. Otherwise, if your name node is not running, then it will give you the error information. Whether you have configured the property or whether if there is any permission issue, it will clearly say. Same is the case with data node as well. So if name node is not running, please go to the logs first and then come to me. Data node not running, please go to this logs and check what is the error. Okay, then come to me. Okay. Okay. Now coming back to again edits log and FS image. So what does edits log have and what does FS image have? Whatever modification you are doing to the Hadoop cluster, right from creating the directories, placing the files from one location to another locations, any modification, any change to the Hadoop file system, that change will be first logged into edits log file as a log appended. Log appended means first transaction, next transaction, third, fourth. So definitely every directory created, every file created in Hadoop, it takes 150 bytes of name node memory. Name node memory. 150 bytes of name node memory. Now fine. Now number of transactions are more means what happens? 150 bytes, 150 bytes, 150 bytes of name nodes memory will be decreasing, right? So in that case, what happens to name nodes memory? It will come down, right? Agree? Now see what happens. I am into this folder. This is data node and this is name node, right? Okay. Now PWD, you are into user local Hadoop logs. Go to CD app Hadoop temp DFS. Now go to name ls space -ltr CD current. Visible, right? All of you, last bench. Now you are into, now visible, all of you. Correct? Right. Now ls space -ltr. What is the size of FS image? 1791. This is bytes means 17 KB something. If you want to know the size in human readable format, H, right? You will be using H, ls-h or ls-lh. Now, what is the FS image size? 1.8 KB means very, very small. Edits log file. What is the edits log file size? 4 bytes. It's almost 0. Now let us see what happens if I do some transactions to this cluster. Hadoop FS -mkdir test1. Okay, I'm just making my cluster busy, test2. test 3, test 4, test 5, test 6. I'm just making my cluster busy. So all this information will be first logged into edits log files, right? As per our discussion. Now let us see the file size. What is the edits file size now? 4 bytes. ls space hyphen ltr. Now what do you see now? It has suddenly jumped to 1.1 MB, close to 1 MB, right? 1048580 bytes. ls space hyphen lh. What is the edits log file size? 1.1 MB. But fs image file size remains the same only. Everybody following into what we are doing? First of all, we are into the name nodes, storage path, app Hadoop temp DFS name, current, and under the current there are two files. One is fs image file system image file, and edits log file. Whatever transactions or whatever modifications we are doing to the Hadoop cluster, name node will first write that modification to this edits log file. So 5 to 6 transactions, edits log file has been jumped from 0 bytes, 4 bytes to 1 MB. Now, if I'm doing continuously modifications for 1 hour, 2 hours, 3 hours, the edits log file size will grow simultaneously, right? Now, let's see this diagram. Suppose let us assume that name node hard disk is, for example, 1 GB. I'm taking very small size for our understanding. Now, in name node, we have fs image and edits, right? Now, when I'm doing modifications, edits log file size is increasing 1 MB, 2 MB, 3 MB, 4 MB, 5 MB. Obviously, name nodes memory will be decreasing, right? Because it is taking name nodes hard disk memory, right? So 1024 MB is going to 1023, 1021, 1020, so on, so on. At one point of time, if no one is monitoring what happens to this name node, it will be full, right? So at this point of time, there is a chance of name node getting failed. It may not work, right? Because it doesn't have enough space or memory. So in that case, what we do is we will restart name node. Once the name node is restarted, it undergoes a process. Let's see this. First of all, I'm copying this data. Right click, copy. Let's see whether it is copying in my notepad. Now here you see what is the size, 1.8 and 1.1. Remember this, okay? Edits log file size is 1.1 MB. FS image size is only 1.8 KB. Now what I do is, I will stop the name node. What is the command to start the name node? Till now you have done start-all.sh, stop-all.sh. Start and stop will start all the daemons or stop all the daemons. Now if my requirement is to stop any one daemon, the command is Hadoop -daemon.sh stop. Select the daemon name, either name node or data node, secondary name node, job tracker or data node. Then that particular daemon will be stopped. Name node. Now here stopping name node. Wonderful. Now JPS. Now I have all the remaining daemons running. Job tracker, task tracker, secondary name node, data node. Because I have stopped the name node. I told you name node is the master HDFS daemon. If name node is down or if name node is not working, your entire cluster is down. Though other daemons are running, if name node is not working, your entire cluster is down. So in this case, say for example, if you are creating any directory, name node is down, right? Now say for example, if I'm doing Hadoop FS -ls /. What does this command do? It will list the file system, means it will read the file system, right? Given enter. You should see this type of output, retrying to connect to server. Retrying because name node is down, right? So it is retrying to connect and it is failing. Connection exception. So whenever you're seeing such type of exceptions, then that particular daemon is not working. Okay, so come down. Now here you see connection refuse. Name node is down. So you cannot do anything in the Hadoop cluster. Though job tracker is running, task tracker is running, data node is running. If name node is down, shutter band. Okay. So now again I will restart the name node. Again, what's the command? Hadoop -daemon.sh start name node. JPS. Now again you see here, name node will be in safe mode if you see for 30 seconds. Whenever name node is restarted. Again refresh 20, 19. What is this safe mode also? Now you will be understanding. Earlier, what is the edit log file size? 1.1 MB. FS image size? Edit size is 1.1 MB. FS image 1.8 KB. Now after restart, let's see what happens. Just open a new terminal. I'm closing this terminal. I'm opening a new terminal. Right click. Right click, new terminal. SU space hyphen space SD user. Hadoop. JPS. All the daemons are running. Now what is the path? Name node storage path. App. Hadoop. Temp. Under temp DFS. Now where you should go? Name. Under name again. Current folder. CD current. ls space hyphen LTR. Now what is the file size you see now? FS image. How much? Earlier it is 1780 or something, 1.8 KB. Now it is 2.3 KB. Slight increase, right? 1.8 to 2.3 means very less increase. What about the edit log file size? 4 bytes. Means from 1.1 MB to it has been reduced to 4 bytes. Means almost 0, right? And again, name node retained its memory, correct? 1 second. Go to this. So after restart, Control V. Now edit log files, FS image file size is 2307, which is in human readable format, ls space hyphen lh. FS image size how much? 2.3. Edits is 4. Edits after restart. Edit file size is 4 bytes and FS image is how much? 2.3. So what is the difference you see before restart and after restart? FS image has been a slight increase, very less increase. KBs means not a problem. But from MB2 it has decreased to 4 bytes, means almost 0. So all this memory has been cleared, right? Then again name node has its own memory, correct? What happens during restart is very important. Name node undergoes a process called checkpointing. Name node undergoes a process called checkpointing. First of all, understand, then write. Okay? During checkpoint, what happens, you know? Name node reads all the information from the FS image. It then replaces all the edits information to the FS image, and then it will create a new FS image dot checkpoint file, which is having the complete information. For example, earlier, what is the file says? 1.7 KB plus here 1.1 MB information is merged into this FS image file, and then it is creating a new FS image dot checkpoint file with 2.3 KB. Don't confuse that it is 1.0 MB and it was 1.7, so it should be 1.27 MB or something like that. All this metadata information is going to metadata and this add existing FS image and then new FS image dot checkpoint file. During this process, name node will be in safe mode. Safe mode means write protected. It will not allow any transactions. It will not allow users or clients to do modifications to the Hadoop cluster. Though it is running, safe mode means it is undergoing a process called checkpointing. So in that it is taking the FS image, it is adding the edits log file and creating a new FS image dot checkpoint. Why it is doing this process? In order to keep the name node health in good size, because if edits log file size keeps on increasing, what happens? There is an adverse effect on the name node's memory, right? So like say for example, there is a dam, reservoir or dam. The main purpose of reservoir is to store water, right? During summers, okay, but during rainy season or cyclones, what happens? There is a inflow of water coming, right? Now they have in gates and out gates for this dam, and then there is one guy or some people who will be working, who will be monitoring this. Say for example, the water level 80 ml or not, there will be like 80, 90, 100, right? So whenever it crosses a threshold, say for example 80, then these people will slowly raise those outward gates, because if no one is opening these gates, the inflow will increase, and then what happens? There is a possible threat to this dam, right? The dam may collapse, correct? Likewise, if these edits logs are increasing, what happens? The name node's memory will be exhausting. The name nodes, it is eating all the name node's memory. So for that reason, what we are doing? We are restarting the name node. So once the name node is restarted, it is going a separate process called checkpointing, wherein it is merging the FS images plus edits log file, and then it is creating a new FS image dot checkpoint file by clearing all these edits log. Means again name node is having its own memory, right? And again, let's do again some modifications. Here, what is the size now? 2.3. Again, Hadoop FS hyphen mkdir test 7, test 8, test 9. Again, I'm making, so what happens now to this edits log file again? Test 11. Now again, if I do ls space hyphen ltr, again what happened? Again, edits log file has been increasing. Again, water is coming to the dam. So what again? What should we do again? Now you tell me what happens if I restart a name node. It will does the next checkpointing, right? So in that case, what will happen after name node restart? FS image file is, for example, ls space -lh 2.3 here, and edits log is 1.1 here. Copy, Control V, paste. Now FS image size is 2.3 KB and edits log file size is 1.1. Now again, I'm restarting the name node. Now tell me what happens. Hadoop hyphen daemon.sh stop name node. It is stopping JPS. There is no name node again here. So if you go to this 50070, it will not work, because only if name node is working, then only this web user port will come. As name node is down, unable to connect to the name node server. Again, I am restarting the Hadoop name node. What is the command? Hadoop hyphen daemon.sh start name node JPS. Now again, what name node does during restart? It will do the next checkpointing, right? So what is the size of the edits log, FS image file? 2.3, right? So 2.3 FS image it will read, and then it will add all these 1.1 MB of edits log file, and then it will create a new FS image file. That new FS file size will be 2. Say for example 2.8 KB or 2.7 KB, very less increase. And then what would be the edits log file size? Almost 0, 4 bytes or something, right? Let's see what happens. Now I'm opening a new terminal. Right click. Okay, now JPS, you can see. Now where is the path I need to go? App, Hadoop, temp, DFS, name, current, ls space -ltr. What do you see now again? Again, edits file has been decreased. So the main motive of restarting or checkpointing process is to keep name node health in good state, right? Now, within a span of 5 to 10 minutes, we have restarted name node 2 times. But in real-time production clusters, it is not a good recommendation to restart name node frequently, correct? Because you have seen this, okay, it has jumped to 1.1 MB. Okay, fine, I need to restart now. But in real time, someone has to monitor this, right? Someone has to monitor this, and someone has to do this checkpointing process depending upon some condition, right? It is a good idea, right? That someone is nothing but secondary name node. Now you understand how they have designed this. So this process we are manually doing. So instead of this, they have created a new daemon called secondary name node, who will do this process periodically. There are 3 conditions. What are those 3 conditions? For every 1 hour, by default, this checkpointing process should be done, or for 1 million transactions of edit logs, or whenever edits log size grows to 64 MB. We will configure these 3 conditions for secondary name node. Till now, are we clear, everybody? What is FS image? What is edits log file? Edits log file is a log appended journal file where every modification you do to the Hadoop cluster, will be logged into the edits log file first. Now name node stores this edits log file and fs image in its hard disk for persistence, means for permanent storage. Now whenever you are doing modifications, the edits log size keeps on growing, which is again an adverse effect on the name node's memory. So what we have done, we have restarted a name node. During restart, name node undergoes a separate process called checkpointing, where it merges the fs image and it replaces all the edits log file to this fs image file, and then it will clear the edits log file, and then it will create a new file called fsimage.checkpoint file, which will be having up-to-date information. As name node is the master HDFS daemon, at any point of time, you will be having the complete snapshot of the file system, which means you take any time, name node will be having the complete information of the files, folders, and what is happening in the cluster. Till date information is stored in name node without missing a single transaction. Now, during a period of 5 to 10 minutes, upon seeing the edits log file size jump, we have restarted name node twice. So this is not a good recommendation, as in production clusters, name node restart should be done frequently, should not be done frequently. For that reason, there is someone who has to do this checkpointing process periodically. So that someone is known as secondary name node. Now let's see what secondary name node does and how it does this checkpointing process. Name node is the master HDFS daemon, right? Means it should be configured with high-end hardware configurations. Secondary name node is also a master daemon. So it is a good practice to have the same configuration of name node to this secondary name node as well. If name node is running on 128 GB RAM, secondary name node should also run on the same configuration. Now, most of the people, most of the students, there is a misunderstanding that for the first time they hear secondary name node means, okay, this is like a backup of name node. But that is not a true perception. Secondary name node is not a true backup of name node. We call this as a checkpoint node. This is also important interview question. What is checkpoint node in Hadoop, they ask? Then you should say secondary name node is the checkpointing node. Now, what are the important configuration files in Hadoop? core-site.xml, mapped-site.xml, hdfs-site.xml, hadoop-env.sh, and then there are two files, masters, slaves. Secondary name node IP address will be given in masters file, only secondary name node address. So from this masters file, name node will understand, or the entire cluster will understand where secondary name node is running. The slaves file means all the information about data nodes. If there is one data node, it will have that particular data node IP address. If there are 5 data nodes, it will have 5 data node IP addresses. Okay. Now coming back to here again, name node and secondary name node. So name node has two important files. What are those? Yeah, fs image, and then the next one is edits log file, right? Fs image and edits file. The metadata structure of name node and secondary name node are configured in the same way. If you see here, okay, in which path you are in? App Hadoop temp DFS, right? CD space 2 dots, CD space 2 dots. Now ls space hyphen LTR. Let's go to CD name secondary. ls space hyphen ltr. Now there is again current folder in secondary name node also, right? cd current. Again, if you see the same, how name node is structured, the same structure has been there in the secondary name node. In other words, the path in name node and the path in secondary name node are same, right? So we have the same. There is this, yeah. Okay. So both name node and secondary name node are in a network, and then they used to constantly poll each other, communicate with each other. For example, let's take 6 to 7 a.m. information. First condition, for every 1 hour, the secondary name node has to do the checkpointing process. Okay. Now exactly 6, for example, 100 transactions are loaded into edits file. 1, 2, 3, 4, 5, 6, 7, 8, up to 100 modifications we have done till 7 o'clock, and all these were logged into this edits log file. 7 a.m. done. Immediately the secondary name node will trigger this condition. Hey name node, it has been 1 hour. I need to do the checkpointing process because I see edits log file size has been increased. So can you please share me the FS image and edits log file so that I will do the checkpointing process and I will be sending you the updated checkpointing file. As the same name node metadata structure on name node and secondary name node are same, so it will have the same information. Now once secondary name node has the same FS image information and 1 to 100 edits log information, this is also stored in its hard disk, right? Now it will does the checkpointing process. Here in this case, we are not stopping name node. You understand carefully. The checkpointing process is done by secondary name node. So what happens, tell me? It will merge FS image plus edits file, and then it will create a FS image dot checkpoint file, which is having all this 1 to 100 information, right? Once it created this FS image dot checkpoint file, once it is having this 1 to 100 information, what it does is FS image dot checkpoint file. It will store this copy in its hard disk, and again it will send this copy to name node. I have done the checkpointing process. Now your memory is released. Okay. I have sent this FS image dot checkpoint file here. So FS image dot checkpoint file is now having 1 to 100 information, right? Till now, everybody clear? Now here you're not stopping the name node. It is still running, which means it is available to the users, right? So users may do some modifications again, right, at this point, because they are not aware of this secondary name node and this checkpointing process. Outside world doesn't know, right? It is purely internal to name node and secondary name node. So during this process, the application teams can connect to name node and do some modifications, right? Because we are not stopping name node. Say for example, during this time period, whether it is 1 minute, 30 seconds, 2 minutes or 3 minutes during this checkpointing, another 40 transactions happened. Let us assume 40 transactions happened. Name node, what it does is it will create a temporary file. It will create a new temporary file called edits.temp, in which all these intermediate transactions will be logged in. Everybody. So name node, secondary name node has already sent the FS image. During that time, new 40 transactions has been logged to edits.temp, means 101 to 140 has been logged into this edits.temp, right? So name node is having fsimage.checkpoint file has how much information? 1 to 100. Wonderful. And this edits.temp is having 101 to 140, means up to date information name node is having, right? So once name node is receiving this fsimage.checkpoint file, it will rename this file again as fsimage file. Means 1 to 100 information is stored in this file. It will rename this edits.temp to again edits file. Now fsimage is having 1 to 100 information. Edits file is having 101 to 140. 6 to 7 information is perfectly loaded in name node, and a copy of 6 to 7 information is also loaded in secondary name node. Now say for example 7 to 730, suddenly edits log file size has been increased to 64 MB. Second condition, there are 3 conditions, right? One is 1 hour by default. Second one, 1 million transactions. Or third, whenever 64 MB is reached, right? Say for example at 730, secondary name node has observed that okay, edits log file size has been jumped to 64 MB. So it will not wait for 1 hour. It will immediately does the next checkpoint. Again the same process. What is there in this fsimage and how many logs are, how much information is there in this edits? It will merge and then it will send a new copy. During this intermediate transactions, what happens? It will again rename that file. All of you following me? So this is how name node maintains the metadata information, and secondary name node, how it helps name node in maintaining its good health. Okay, just I'll can someone come here? Anyone? I asked to come, not to talk. So secondary name node, I'll tell. That's wonderful question. I'll tell. Come here, come here. No, no. Don't make noise, okay? Line by line. Clearly read, okay? Just read line by line. Line by line read, okay? Don't be happy. Yeah.
Secondary name node is one of the poorly named component in Hadoop.
Stop.
Secondary name node is one of the poorly named component in Hadoop. By its name, it gives a sense that it's a backup for the name node. But in reality, it's not. Lot of beginners in Hadoop get confused about what exactly secondary name node does and why it presents in HDFS. So, by its name, you may assume that it has something to do with name node, and you are right. So before we dig into secondary name node, let's see what exactly name node does. Edit block, FS image.
Now, including the master data, and it is having 2 important files where it stores the metadata information. One is FS image, and then the other one is edits. Now, name node is writing all the modifications to the Hadoop file system. I mean, edits log, and then this FS image is reading at the starter and merging with edit logs. So, name node holds the metadata for the HDFS like namespace information, block information, When in use, all this information is stored in the main memory. Main memory means RAM. RAM. Main memory means RAM. It will store this information in hard disk as well as this information in RAM also. But this information also stored in disk for persistent storage. Whenever you are storing in hard disk means it will be permanent. RAM memory, if power loss or anything, it will be wiped out. Right? So name node stores this important metadata information in hard disk as well as in RAM memory. Now this is what we have discussed, right? Edit log file, FS image. The above image shows how name node stores information in disk. Likewise, read it. Good.
Different files are here. One FS image. It's the snapshot of the file system where when name node started. Second is edit logs. It's the sequence of changes made to the file system after name node started. Only in the restart of name node, edit logs are applied to FS image to get the latest snapshot of the file. But name nodes restart are rare in production clusters, which means edit logs can grow very large for the clusters where name node runs for a long period of time.
Obviously takes time, right? So during that particular time, neighborhood has to be downstairs, which is not a good sign, right? So that is what they are saying. But neighborhood restarts are made in production clusters, which means edit log can grow very large for the clusters where name node runs for longer periods of time. The following issues will encounter in this situation. As discussed, edit log become very large, which will be challenging to manage. Name node restarts long time because lot of changes has to be merged. In the case of crash, we will lost huge amount of metadata since FS image is very old. Name node goes down, there is a chance of losing your valuable metadata, right? So for that, to overcome these issues, we need a mechanism which will help us reduce the edit log size, which is manageable, right? And have up-to-date FS image so that load on name node reduces. It is very similar to Windows restore point, which will allow us to take the snapshot of the operating system. Okay, so now we understood what name node does and challenges to keep the metadata up to date. These are the challenges. Now let's talk about secondary name node. Secondary name node helps to overcome the above issues. What are the above issues? Long hours of running edit log files, okay, keeping old metadata for long time and everything. So secondary name node helps to overcome the above issues by taking over responsibility of merging edit logs with FS image from the name node. So here we have a name node, we have a secondary name node. Now secondary name node, the arrow is pointing to name node. It is asking for edit logs in regular intervals. What are those regular intervals?
After 64
1 hour by default.
1 million transactions. 1 million transactions.
It gets the edit log file. What it is doing? It is updating with FS image, and then it is sending the updated FS image back to the name node. So this is what name node is doing. The above figure shows The working of secondary name node. Secondary name node gets the edit logs from the name node in regular intervals and applies it to FS image. Once it has the new FS image, it copies back to the name node. Name node will use this FS image for the next restart, which will reduce the startup time, right? So the whole purpose of secondary name node is to have a checkpoint in HDFS. It will continuously monitor name node health. So it is just a helper node for name node. That is why it is also known as checkpoint node inside the community. Understood? All secondary name node does the checkpoint in file system, which will help name node to function better. It's not the replacement or backup for the name node. So from now on, make a habit of calling it as a checkpoint node. How name node stores the metadata information? What are the two files?
Size increases. Secondary. $64 MB. 1 million transaction. 1 million.
So name node, what's the main responsibility of name node?
Data.
Handle the what is secondary name node responsibility?
Checkpoint.
Someone asked me why have this secondary name node goes down? Fundamental question. Secondary name node, there are example of pixel current has to do as the backup of copyright is down. Now you can think about it, secondary because the checkpoint is storing markers, right? The data is not stored in markers, then it is an issue. Because secondary name node from copying markers, right? So if the result of markers information and in the running again, new stuff. Right? It could close down that that's the issue. And name node is a single point of contact or single server running is known as SPOS, single point of failure. If name node goes down, actual cluster is down. Right? So what are the 5 demons? You can sit. Yes. I'll come back to you. I'll come back to you. That I'll tell you. It copies FS image dot checkpoint, right? One it will store and one it will send to name node. Yes, hard disk. In its hard disk one, and then it will share that copy or it will send that checkpoint file to the name node. Okay. Now, what are the 5 demons? Tell me. In 1.x version, we have name node, secondary name node, data node. Now, these 3 demons are mainly responsible for storage, right? So, whenever you're discussing about storage part, name node, data node, and secondary name node is concerned for name node's health. What are the remaining 2 demons? Job tracker, task tracker. So this should belonging to processing, right? As Hadoop has 2 components. One is storage part and processing part. Storage part of Hadoop is known as HDFS, and HDFS is handled by name node, data node, and name node health is handled by secondary name node. Now, what about processing? If you submit any job, who will be taking care? So there comes the important daemon called job tracker. So job tracker, what is tracker means? What does tracker mean? Which tracks? For example, you purchased a product in Amazon. You have an order tracker, right? track your order. So it will tell the perfect status of your order, dispatch it from warehouse, in transit, reach it to your nearest warehouse, delivered by tomorrow. It will give you the perfect status, right? So job tracker, it tracks your job. Job tracker is the master processing daemon. Job tracker is the master processing daemon. Who is the master storing daemon? Who is the master storage daemon? Name node. Job tracker is the master processing daemon. Now, what is the responsibility of job tracker? The main responsibility of job tracker is scheduling and monitoring. The main responsibility of job tracker is scheduling and monitoring. Scheduling and monitoring means it will schedule the jobs. Not interested? I told you, right? I will not tolerate some expressions while telling the class, okay? So don't give those expressions, please, okay? Yeah. Morning, right? Enjoy the weather, enjoy the class, okay? I'm not eating, only 1 hour only I'm taking, right? Please. Okay, okay. Monitoring, okay? If it is boring, I will not say, okay? So job tracker main responsibility is scheduling and monitoring. So it will schedule the jobs and again it will monitor the job. Coming back to our 1.x version, if you have started start-all.sh, you can see all the daemons, right? Like once you give JPS, the process ID, name node, secondary name node, job tracker, data node, task tracker. Suppose I have stored a data of 192 MB. How much? 192 MB file in Hadoop. So how many blocks? 3 blocks. As the replication is 1 in single node, this will store 3 blocks, B1, B2, B3. Let us assume that this is some geo data. Now your data is stored. Wonderful. I have written a program to process this data because until and unless you process, you will not get the analysis, right? So you are doing some program to get some information on these blocks. Now, any program you have written in Java, for example, it is Hadoop 1.x. The processing part is map reduce, right? So as Hadoop is completely written in Java, okay, map reduce programs are written in Java only. But don't worry about Java and everything. Okay, forget about that. You have written a program to analyze this data. Any program submitted to Hadoop cluster should be in the form of a jar file. What is jar means? Java archive file. Means your code will be bundled as a jar file. As I told you, once you install Hadoop, if you see, where is your Hadoop installed? Where is your Hadoop installed? User, local, Hadoop, right? Under user local Hadoop, if you see, okay, what are these? Hadoop tools.1.2.1.jar. Again, test.jar, mini cluster.jar, examples.jar. There will be some programs bundled as a jar file. If you remember, standalone mode, pseudo distributed mode, fully distributed mode. In standalone mode, we have discussed that the standalone mode is mainly useful for testing the jar files provided by the framework, right? So any program written in Hadoop should be submitted in the form of a jar file, Java archive file. Now say for example, this guy has submitted a program to the Hadoop cluster in the form of a jar file. that program is considered as a job. One job means one program running or one application running. 5 jobs are running in my cluster means 5 programs are running. Okay, 5 programs are nothing but 5 jobs. A job is nothing but a program. Now, suppose this guy has submitted a job to process this data. Now, who will be taking care of this job request? As it is processing related, job tracker comes into picture, right? Because any storage related information, name node will be connected. Name node will assign the blocks to the data nodes. But now I am submitting a job, processing job. So job tracker is the master processing daemon, right? So it will comes into picture. It will take the request. But do job tracker have the metadata information of that particular blocks? No, right? Only name node will be having the complete information of this block on which data it has to process. So whenever job tracker gets the job request from the clients or users, it will internally check with name node. Hey, name node, I was given a job request to process block 1, block 2, block 3, but all the metadata is resided in you. You know the information, right? So can you please share me the details of the block so that I can process? Once name node shares that information, like, okay, your data should be processed on block 1, block 2, and block 3. So job tracker will now get the block information from the name node. Now it will responsibilities scheduling and monitoring. How it will schedule the job? Job tracker is the master, and who is the slave? Task tracker. So job tracker, any program it is coming or any code it is given, it will give that code to the slave node to be processed. Job tracker will not process, it will tell the slave to process. Who is the slave here? Task tracker. Now there is the task tracker here, right? Now this job tracker will give that code to this task tracker to process. Now, how do this task tracker processes? How do this task tracker gets the resources? Let us see. Whenever job tracker is giving resources to the task tracker internally creates a new task instance, which is nothing but a new JVM. What does JVM stands for? Java Virtual Machine means a runtime in an environment to execute your program, in which by default it has 2 map tasks and 2 reduce tasks. What is that? 2 map tasks and 2 reduce tasks. Map reduce. Processing layer of Hadoop is known as map reduce. So you can break the map reduce into 2 parts. So this task tracker will now have 2 map tasks, 2 registers by default. When I'm saying default means you have the flexibility of increasing, right? Block size default 2 MB. Block size application default 3. Likewise, 2 map tasks and 2 registers. Now what happens this task tracker is it will take the request. How many blocks are there here? So how many map tasks are there here? So mappers and reducers run independently. They run isolation. They don't work with each other. Mappers run independently, reducers run independently. Mappers phase is completed, then only reducer phase will start. These are all basics. Mappers will not involve in reducer tasks. Reducers will not involve in mapper tasks. So how many map tasks are there? 2, right? So mapper 1, mapper 2. How many blocks are there? 3 blocks. So job tracker will now tell this task tracker to process these 3 blocks with that code. Now task tracker has 2 map tasks. It will first process block 1. It will first process block 2. Like how data nodes, they are sharing heartbeat signals, right? These task trackers also send the heartbeat signals to job tracker only, telling that they are processing or they are live and active. So from this information, job tracker will know which task tracker is running. As this is a single node, one task tracker is available, right? So the task tracker is sending heartbeat signals to job tracker, and it is processing two map tasks. Mapper 1 is processing block 1, mapper 2 is processing block 2. Block 3 has to wait until either of this mapper 1 or mapper 2 has processed these two blocks. For example, mapper 1 has processed block 1. It will now become free. Now the job tracker says, hey, mapper 1, you are free, right? Now there is one more block. Please process this. Right? So again, the task tracker will process that block. Process is nothing but it will run the same code on block 1, block 2, and block 2. Right? Now, the mapper, while processing, it will send the periodic updates like 20% job completed, 30% job completed, 40% job completed. Once 100% is done, then job tracker will get the complete information from the task tracker. Then it gets the output and it will send to the client. Let me show you with one example. What is the name node web UI port number? 50070, right? Now job tracker has also web UI port number 50030. How much? Now if you do localhost colon 50030, what does this say? Hadoop map reduce administration. All of you. Running map tasks how many? Running reduce tasks how many? Because we have not yet submitted any job, right? Then nodes, how many nodes are there? Only one. Map slots 0 because nothing is running. Map task capacity how much? 2. 2 map tasks and how much? 2 reduce tasks. So for every mission, there will be a 2 map tasks and 2 reduce tasks. Scheduling information, default scheduling. There are no running jobs. So how to submit a job? Go to the terminal here. First of all, understand this. How the job tracker is doing. Now type Hadoop. Whenever you are doing Hadoop FS prefix, you are connecting to file systems, right? Now there is a command called, what is this? Jar file. Run a jar file. So in order to run any program, you need to use Hadoop space jar. Hadoop space jar. Hadoop space jar. Now it is asking what is the jar file I need to select. The framework has provided you certain jar files, right? What is this? Hadoop examples 1.2.1 is our version name .jar. So I will run this jar file and see what are the programs available. I know your feelings, okay? Just once 5 minutes, I'll give you a break, okay? Okay. Hadoop space Hamaya. Hadoop space jar. Hadoop hyphen examples. Now, what are an example program must be given as the first argument. What are the example programs, valid programs here? Right. Okay. Now the valid programs are aggregate word count, DB count, grep, and if you see there is a pi program. What is the value of pi in mathematics? 3.14, right? 22/7. Now the same program is written in MapReduce, okay, using Monte Carlo method. Okay. Now let us use this same program. Upward arrow, pi job, enter. Now what it is asking? Pi estimator, n maps and n samples. In order to run the pi program, please submit how many maps I need to take, how many samples you are giving. So what I do is, understand how the job is running. Upward arrow, 2 maps and 2 samples. What is this 2? You will understand now. Number of maps, how many? 2. Samples for each map, 2. Now see running job. Map 50%, 100%. Then register phase will start. Once mapper 100% is done, then register phase is started, right? This is job how is done. Job finished in 14 seconds. Estimated value is closely 4. Now if I go to this Mozilla Firefox, if I do a refresh, total submission how many? 1. Completed job. Every job there will be a job ID. Started time, priority normal. Who is the user submitted? Name of the job. Job is successful. So mapper 100% completed. Total maps how many? How many completed? Register is also completed. How many registers used? Though it has 2 registers, only 1 register is used. Okay. This program, how we train and everything, will take a break. Okay. Time is 8:30 is fine. Huh? Someone Mohit sir, someone please stop this recording. I checked with Kapil. He said that some pause will stop. It will share. It will share, but recording will be in process, right? Screen sharing will be paused. Huh? Recording will be paused.